large topic. But today we are going to be talking about commercial design considerations that are found within the Energy Code itself. This is more of a broad general overview of the many different things that come under the Energy Code. And then as time comes by, whether in person, during our in-person or during our webinar series, we will do deeper dives or more intense reviews of different subjects, specifically sections within the code. But our mission at the Minnesota Energy Code Support Program is to support and educate and empower you as building professionals throughout the state to in the construction of energy efficient buildings that benefit the community and the overall environment, and also to promote code compliance. We don't really push anything that's as much as we're just trying to make sure that we support you in whatever resources you need. Please feel free, if you have questions, to reach out to Hope, Gil, or myself. You can always email us at mnecsp@shums. Go to the website, check it out. And again, we always look forward to more information. We're adding more resources to the website. We added some technical resources this week. Probably uploading the webinars probably later this week as well. And again, just trying to be a resource to you and the community. We'll talk at the end about some upcoming in-person trainings as well as future webinar topics. But again, if you have an interest or you have an issue or a question, or you want to host a training, let us know, and then we can try and set those up. And again, just as a reminder, when we say free, we mean free. And so we'll talk more about that. But we need to get into it so that I can get us done on time, because we have a lot of slides. You will get the slides at the end of this, so if you have any questions, feel free to reach out. Or if I don't get them all done, at least you have the information. So one of the things that I think is fundamental, and I always think is important to reinforce, is this concept that if we understand the why of what we do, then we can figure out the how. And in the context of what we're talking about building codes. Why do we have building codes? Well, we know that the building code was adopted and is enforced so that we can provide some basic and uniform performance standards, right? We want to know how buildings are built in our community, and that when we say it's built to a standard, that we know what that standard is and that we're consistent. Literally, we're in conversations all the time with people around the country, and we were in one just this past week. I was in a conversation, a back and forth email series with a bunch of different building officials, and that's one of those things that we just think is fundamental, right? Code compliance is does not always sound the best, right? It's not the hot topic people want to write home to mom about. But when we see failure, it sure is important to understand. And so I think part of, there was an old mantra years ago that was always called, when we do our job, nothing happens. And I think that's not the right attitude. I'm campaigning for a future shirt that says, when I'm successful, nothing fails. Because again, that's what we're doing. We're building, we create and establish building codes to provide a basic understanding of what a C+ building, a minimum standard, is going to be. Now, there's always going to be better, but we want to make sure there's nothing worse. And so we're looking at concepts like, how are walls built? How are roofs designed? What are live loads, dead loads, those kinds of concepts. And in that, we also understand that the Energy Code comes into play to assist us in making sure that the buildings we do design operate effectively and efficiently for their useful life, right? That we're controlling concepts like heat loss and illumination and climate control, right? Within that building, the code is all about control. We want to control how a load is transferred through a building system, right? And we want to control how energy and how heat or HVAC or conditioning concepts are controlled. We want to control those things. It's okay to want to know when your lights are on. It's okay to want to know that your building wall is going to support the things that you're trying to accomplish. And those are design considerations that I think are important. Now, we have reached out, and again, not to get too much into the weeds already, but we continue to reach out to building officials. So again, if you have other contacts that you think would enjoy or find interest and get some of the to join us on these webinars, feel free to share those information, those contacts, either with us or share it within the registration link. And as well as architects and builders. This is not just for building officials. This is for the building community, because we want to make sure that as much as we know as building officials and building inspectors, that we also have on contractors and design professionals. And especially when we consider some of these concepts like design, it's really helpful when we have design professionals. So again, hopefully there's a few of you on here. Last week when we had our training, we had about 20 in the class, and we had one design professional and a bunch of building officials. And it's always great to have that other opinion once in a while, even though there wasn't much, divergence of conversation, right? But really, we think about design of a structure that's going to comply with the energy code. What we're thinking about is flexibility. So the question on BOL, the question in the chat is whether we need to put in a license number. The answer is technically you can put in a space or an NA. So we do offer ICC and AIA credits as well. So like if you have an architect, they can put it in their AIA number as long as they tell us that's what it is, or they can put not applicable. I will reach out to those people that don't, and all they have to do is push space or push an NA, and it will allow them to register. If I could control Zoom better, I would put in a little note that says that, but it doesn't exist in that capacity. But again, when we think about, a good question. When we think about design considerations, we really think about it in the context of the 4 basics, right? And that's what we're going to try and hit very high level today. Like I said, we can dive down deeper later in different classes. But we're thinking about, if we're going to build a commercial project, we're going to build a convenience store in our community. We're going to look about the building thermal envelope. We're going to look at the mechanical systems, the service water heating systems, and the power and lighting controls and considerations. Now, we know that when we think about the code tells us that the standard is designed to address a variety of different components or concepts in new construction and alterations of existing buildings. And it also reminds us what it does not do. Sometimes it's important to know what it does not do. And this does not address those single-family, two-family dwellings, townhomes, and those IC4 facilities that are identified. And that's when we're going with that. Those occupancies that are going to be in that residential are going to follow the residential provisions. And so again, we'll talk about that. But again, those are those multifamily structures that are under that 3 stories or less above grade. And those will be following commercial provisions for energy, but maybe residential provisions for energy that may be following commercial provisions for construction. But again, we talk about how, as it was adopted, the state adopted the ASHRAE standard to include chapters 1 through 12 and appendices A, C, and G. And so we're going to focus a little bit of our conversation on how do we demonstrate code compliance in our design. And very briefly, and I'm just going to run through these very quickly. There are certain considerations that when we think about the scope of a project, we think about how they're going to be applied. One of the things we think about is new buildings. And in the concept of new buildings, we're going to be looking at how does the, section 4, which is more about the administration and components, is going to tell us that we're looking at complying with the sections 402.2 through 402.5, as well as the provisions of building envelope, heating, service water, power, and lighting, right? The same concepts we talk about. So they're going to comply with the code in that context. And part of what they're looking for is how are we going to provide, what's the compliance path? Those compliance paths include prescriptive compliance path, which is that follow the code, do what it says, right? And quite honestly, I've said it a million times, if there's anybody that says, just tell them what to do, they're usually not exactly going to be honest with us, right? They don't want us to tell them what to do. They want to give us a bunch of reasons why they want to do what they want to do. But we're not going to get into that. We don't have time for that long conversation. So you have prescriptive compliance. You have energy cost budget calculations, where you're looking at the cost to operate that building versus a standard design of the same size and capacity, or same design and certain expectations. And then you have the performance rating, which is, again, another analysis looking at how is that building performing, not necessarily dollar for dollar, but as a system, how's that building performing? So again, there's alternatives that we can look at, and they're going to have different things that they have to comply with or demonstrate and document for us as far as a project. But when we think about how the code is laid out, the code provides us some very how do I put it? These basic expectations when we look at a code section. If the second digit is a 0.4, then we're looking at mandatory provisions that are mandatory across all different compliance paths. Then we have prescriptive at 0.5, and one of those alternatives is at 0.6, right? So we're looking at, so again, when we think about certain considerations, you're gonna find mandatory provisions that exist in multiple places within depending on a project's compliance path, right? And so again, I just very quickly remind us, when we're thinking about that energy cost, we're looking at a system that utilizes some type of mechanical system, right? It does not work to calculate energy costs when there's nothing that's using energy, right? So again, that's one of those considerations, one of those expectations, if you're going to use that system to calculate. And what it's going to tell us is that if we use that system, it gives us a variety of different sections in all of those 4 different key areas and that we're going to comply with. And again, the same concept if we're looking at performance ratings under Appendix G, it gives us those same, you can't see my laser wasn't on. It gives us those same expectations as far as what sections of each of those respective 4 concepts are going to apply. And so that's where, again, when we think about new buildings, we're thinking about it from how do they operate in the context of those different areas and what compliance path we're going to be utilizing. It also, the code applies to the new portions, new systems, and equipment that are installed in a potential project. And also, the code addresses the concept of additions to existing buildings. And so the code provides us, if we look at 4.2.1.2.1, it tells us that we can those additions and we can utilize the various compliance paths as well. So again, understanding compliance paths is one of those key concepts. And when we talk about, whether we're talking new buildings, alterations, additions, all those different concepts, we can see where the compliance paths are important to know. When we talk about some of our in-person trainings, if you're thinking about attending some of those, one of the key concepts we hit usually in a lot of our trainings is going to be the concept of compliance path identification. Because when we understand what compliance path, then we can better isolate and determine what it is that we're actually looking for as far as considerations. So again, we're looking at those concepts of, is this prescriptive? Is this going to be an energy cost analysis that we're looking for? And are we going to be looking at different performance measures and criteria? And so, and again, we're going to treat a building that when we see a change in space conditioning, and remember, we sometimes talk about unconditioned or semi-heated versus residential, non-residential heated areas. Then if we're going to see a change in that conditioning, we're going to treat it as a new building. So again, things to consider and as we think about all the things going on. So one of those key first considerations, not only are we going to identify what compliance path we're going to follow, but we also need to think about what area we're in and how we're going to identify the conditioned spaces within that building. Remember, when we talk about mixed occupancies, again, we're gonna isolate those I and R occupancy types from and treat them differently from the other building occupancy types that may be in that mixed occupancy building, right? So we're gonna have sections that are gonna be treated a little different based on their occupancy type because we have certain expectations for the different designs. But what we know about the code is the code is really fundamentally pushing us to knowledge, right? Control, it's like I say a lot of times, the more I know, the more I can be comfortable in approving a project. And with that comes the recognition that we need to know what's going to be done in that project. And we expect that information on our construction plans. And so those construction plans are going to include concepts like, what's my compliance path? What's my thermal envelope? What are the systems? What are the controls that are in place? And the code gives us a large list or a longer list of 18 specific concepts that we're supposed to identify. And compliance paths is, again, one of those key components, as well as the different systems that we're going to talk about today. When we think about it in a design consideration, we're just going to look at new buildings because it's just easier, right? what we're going to be looking for is that building's envelope, right? We understand that the envelope exists out of that system of walls, floors, seat roofs, right? All those elements that distinguish and separate the exterior environment from the interior spaces. And one of the key considerations that we have to think about is not only how is it structurally supported and what are the thermal resistance, but then concepts of like, and I use plumbing as the example, but protection of different MEPs and different systems within that building, right? If we're not protecting and considering maybe the whole building as a system, then there's the potential that our building thermal envelope or our building envelope will not adequately protect systems like our plumbing. That's usually a good one for me, just because that's the one that I think is most often affected by changes in temperature, right? Electrical conduit, maybe not so much, but and HVAC to a degree, but plumbing is one of those things. If it's not properly insulated, not properly located within the building's thermal envelope, it's going to be the most affected, most obviously affected when it comes to freeze thaw. And you guys know that just like probably more than some of the lower, the more warmer climates, right? But when we think about the building thermal envelope, there are certain mandatory considerations. And the primary one that we always go to, right? Whenever we think building thermal envelope, whenever we think building envelope, our brains automatically tend to go straight to insulation, right? We think about what is the insulation and what is the insulation values. We understand there are R values, there are U values. We'll talk more about thermal envelopes in our in-person trainings as we move around the state as part of that project. But, you know, what we're looking for is how does this building from a prescriptive element, you know, we have mandatory provisions to evaluate the thermal envelope and install a level of installation. But from a prescriptive measure, we've got these tables, right? The tables that everyone says, tell me what to do and I'll do it. And so in those tables, we identify all those different systems and we'll have deeper conversations about that. But remember, when we look at those tables, what we're looking at we're isolating them by both our space type as well as our assembly or component type. And then within those components, we're going to identify their R values, U factors, their heat conductance capacity. That's that concept that when how well or how much heat does a particular material resist, or how much heat transfer does a material resist, given a measured amount of time and space, right? And so we generally relate that down to what's an R value or a U factor. Now, R values and U factors are inverses of one another. So as the U factor goes down, the R value goes up in number, right? But they can be, it's a very simple mathematical calculation. You can multiply, you can do the division either way, do the equation, and the two values equal out. And so when we calculate those values, now remember, these values have been around for a while. You know, one of the questions we'll ask it sometimes is how long have they been around? And for most people, they don't understand. We immediately think of R values, at least a lot of conversations, we talk about R values and U factors, and we talk about them in the context or in the expectation that they're recent, they're new, they're new concepts that came out of the 70s with the oil crisis. Not exactly true. U factors have been around for hundreds of years. R values the R value was established, created back in 1945, if you can read that little plaque there at Penn State University. And so these concepts have been around. If you think about the R value, almost 80 years, we've been using R values to measure thermal resistance. And we've been using the concept of the U factor even longer, right? Because we're looking at the transfer of heat through square feet, through a material, right? BTUs per square foot per hour per square foot. And so what we're doing is we're adding up all the thermal resistance capacities of all the different materials within assembly, and then we're calculating a potential U value. Now, if we were looking at a wall system like the one we see here, which we're not going to spend a lot of time on, we would see that it comes out to a U value of 0.057. Well, if we were to apply that to our U value, we would see that in a non-residential structure, that is above. We're looking, this is the maximum number, and that is above the maximum, so that it would fail. And this is the minimum R value. So we need an R13 plus 5.7, 7.5 continuous. And that was a wall that had 13 with 3.57. So again, it's not going to match. It's not going to work. And so we're going to have to find some alternatives. And that's part of that design process. Identifying what is the appropriate level of insulation in that building envelope, given my climate zone and given my material or my wall system or component type, right? And so if we were to start to increase this value in our wall, if we just increase the R value, the cavity value, left the 3.57, we could get with a 17, we can get to a 0.48, which would be lower than our U factor assembly measure. So again, that R17 plus 3.57 would pass, would be acceptable in the climate zone 6. So again, that's if you have questions, please raise your hand. But that's usually what we're looking for, right? We want to make sure as we design that building thermal envelope, we want to make sure it adequately meets the expectations that the code provides. And the code provides us a great deal of flexibility in reaching that value. I threw in an R19 and R21. What would be different values and what would be their respective U factors associated with a particular design? The code is designed, it's not just give me the R13 or the R19. It's, if I look at the U factor, I have a variety of flexible options there. And so I have to hit one or the other. So I either reach my U factor or I comply with my R value calculation. When we think about that in some of those different compliance paths, what we're going to see is maybe through one of the appendices or through the building trade-off, we're going to see reports provided that demonstrate how those wall systems comply with the thermal envelope expectations. But that's not the end of the story, and we'll always have more conversations about thermal envelope. The thermal envelope, the building envelope, doesn't just include walls. We all know that if we lived there are days we feel like we live in a concrete box, but in all reality, we don't. We live in buildings that have windows and fenestrations and doors, right? And so those fenestrations and doors have values as well within those tables. And so whether that's an opaque door, a vertical fenestration, or a skylight, we have different minimum U factors and solar heat gain coefficients and visibility transmittance levels that we're expecting to see in the features in these components when they exist within our building envelope. So again, if we were looking in, this is climate zone number 6, I've got my insulation in my cavity. Now I need to think about how a fixed or operable window, what are those expectations of those elements within my building? And so we're going to have those factors, U factors, those solar heat gain. Again, like we've talked about before, the U factor is again that variable, that calculation of heat transmittance, and solar heat gain is the ratio of solar radiation that makes it through an assembly into a space. If you think about it, solar heat gain is if I'm looking at a window right here, that solar heat gain coefficient is what affects how much radiative heat comes through that glass into the occupied space. Again, a huge consideration when we're calculating the relationship between the building thermal envelope and our mechanical systems, right? The more that we allow heat into the building, the more we have to condition and control that heat or that cool once it comes into the building. Remember, heat generally, solar heat gain affects the heat coming in. U factor will affect the heat going out, although U factor affects both. But so a better U factor will resist heat transfer or controlled conditioning leaving that system, right? So it's going to prevent some of that inclusion of the heat coming in, as well as the cool going out. And we think about that also in the context of winter, right? And so if we've got the better the better the U factor value, the better we control and keep that heat inside the building and don't allow it to move out into the cold, into that inverse exterior environment. Concept of the solar heat gain is much the same. The number reflects the percentage of radiative heat that comes through. And so a solar heat gain of 0.86 is going to allow 86% of the radiative energy, radiative heat through that wall system, whereas 0.30 is 30% is 0.3 is going to allow 30% of that radiative heat conceptually through those windows. So again, depending on our building, if we have a large building with a lot of glass, we don't want it to allow all of the heat that comes into the day to go directly in and affect our heating. And so we have these concepts like solar heat gain coefficients. And if you remember back to, if I click the right button, go back here, our opaque window is 0.34. We're hoping to only allow 34%, no, sorry, 38.38. In a fixed window, we're hoping to only to allow 38% of the radiative heat into the through that window system, right? And then that's the maximum value. We can always go lower. And so when we think about controlling that, we also think back, I always go back to the concept, and one of the things that the energy code identifies is the concept of projection factor, right? When we think about it, and again, sometimes it's easier for me to think about it in grandma or in old school residential communities. So grandma has a huge porch, a wraparound porch, because she's trying to she's trying to keep that shade to keep the heat out of the living room. Same concept applies in commercial applications, right? We provide these large overhangs to block the direct sunlight into our windows. And so so projection factors can have an impact on how a building operates and how much, and how we also evaluate certain types of solar heat gain coefficients, right? That shading is not going to prevent the air leakage, but it is going to affect how much direct sunlight that building would get. And that's where we go back. If we go back again, sometimes we'll see some of those values start to come out in different calculations, and especially in different softwares when we look at some of those performance measures. Again, when we're thinking about air leakage, that's again, we're looking at how are these systems, how are all these windows going to operate? And so I'm expecting that the code's going to provide me some calculations, some maximum air leakage rates that I should have when I look at different types of windows that are either brought on site or constructed on site. And it also provides us recognition of the different NFRC calculations and standards that we can use to calculate on site values. And so again, we want to make sure that we verify these walls, these windows. I mean, we spend a lot of time considering all that goes into the wall itself. And then if we ignore the windows, it's like leaving that giant gaping hole in the building, thermal envelope, right? So it's all part of the same system. Secondary, as a part of that relationship is going to be the design considerations for mechanical systems, right? The code tells us that we need to look at either the simplified approach or our prescriptive compliance process. And so we're going to be looking at how does this system operate? How is it providing the heating and cooling, right? We've got the building thermal envelope, but the building thermal envelope can't do it alone if we're looking at a building thermal capacity and design. It works with our mechanical systems. And so if we're following that simplified approach, we're looking at a system that's based on a size, as well as a building that's based on size, and then a system that's based on 19 different criteria. Now, I've only listed the very highest. We're going to have some conversations about mechanical systems where we'll get more into those. But again, they're going to make sure that these are going to be, if we're looking at it as a simplified approach, we're looking for a simplified system. We're looking for one zone. We're looking for equipment that is efficient. We're not necessarily driving the conversation saying, this is how many CFMs of air we need to move and what types of temperatures and that kind of thing, as much as we're making sure that we control the environment that we have, right? We want to, again, control when that system is operating. And that's the name of the game, at least in building construction, in my opinion. It's all about control and giving that owner the ability to control their own building. If we follow those mandatory provisions, again, the code tells us a variety of different equipment efficiency expectations, right? We go back to the mechanical code to tell us what kind of system and what the expectations are for loads and designs. But then we go back and make sure it's efficient when it comes to how it operates. And then it gives us a variety of different calculations to assist us. And so again, if we're looking at a project, we're going to be looking at what are those individual pieces of equipment and how do they rate. Now, this is a cutout from a project that utilized a comm check, which we know that DOE and P&L are working on Minnesota's comm check system. We're still, it's there, and we're still making sure that we're looking to make sure everything works. And so it's always one of those things that you too can always check and verify that things are. I appreciate a good system that tells me I'm doing it right, but I also always I always like to do my own verification to an extent, and that's exactly what this is an example of. So the ComCheck report tells me that this is great. I verify that with my equipment. My equipment is telling me that if I'm utilizing a gas duct furnace, a warm air gas fired furnace, and that has 130,000 kTBTUs per hour, then my minimum efficiency for weatherized or non-weatherized is going to be 80. And so I'm verifying that the proposed efficiency is 80. And so I can verify those values, right? I'm going to verify them against all those 20 different tables that exist to give us that list of all the different potential materials that could be utilized. Same concept with the cooling, right? I'm looking at a cooling system that provides me with 56,000 kTBU. I'm looking, oh, I grabbed the wrong one. So I'll be looking at that value, comparing it to what would be the appropriate size, which in this situation, I'm going to be looking at the wrong size. And then I will be looking, I can verify that, well, these minimum efficiencies, does that match? And then we can verify those things. And maybe, again, this is how we go through plan review, verifying that what's in the plan matches what the code requires. Not just that we accept that, hey, it's got a green bar, I'm done. That's not the way this works. We want to make sure that we take pride in what we do in both our design and our plan review. And so we want to make sure that we spend that little bit of time verifying the equipment they proposed matches with the tables that are in the code. And part of that is also given the reality that sometimes it is very easy, and we'll do some ComCheck, ResCheck classes just to show you how it operates, how it works. But I think that's one of those things where you can easily, if you've done a ComCheck or watched ComCheck or one of those calculation systems, then you can see how it might be easy to make a mistake and maybe put in the wrong values, the wrong elevation, the wrong considerations and values. And those are something that we'll talk about in some future trainings as well. Part of the mandatory provisions of the code when it comes to HVAC systems relates to controls and diagnostic expectations with automatic shutoffs and setbacks and zone isolation. These are concepts that when we talk about mechanical systems in a little bit deeper conversation, we'll get into more. But again, we need to understand that these expectations are mandatory, right? If a system is there, we need to make sure it's being installed properly, right? When we think about the installation, the construction and installation of our systems, the code again provides us mandatory expectations for how these systems should be insulated, how they should be sealed, how they should be installed, right? And whether we're thinking about and when we look at that table, again, we're looking at how does that table reflect the area. And now this one is the model one. I've got another table I'll probably add in before I send this to you as the actual handout that incorporates the state's modifications and changes. So we'll move on. Again, there are other expectations when you think about a project from a prescriptive compliance measure, different systems that maybe, whether we're thinking controls or equipment that may be installed. And so again, being aware what system, what compliance path am I utilizing can affect how we're going to design that building. And those are going to be concepts of when do we need to have air economizers? When do we need to have heat rejection equipment? How are exhaust systems going to operate, or energy recovery systems operate? If they're in place, how are they going to operate? What are the expectations? And when we talk about mechanical systems, it's a huge conversation, and we've got an upcoming training that you may be able to be a part of when we do a little deeper dive. As well as some of the water heating service water heating controls. It's all about control. It's all about making sure that we don't waste energy and potentially water turning on a faucet and waiting 5 minutes for it to warm up, right? How are we controlling the concept of heating that service water, right? Of hot water delivery. We talk about concepts like heated pools or equipment efficiencies. If we have gas-fired water heaters versus different equipment, what are we thinking about heat traps so that we're not constantly retempering that same water heater, right? So a lot of calculations can come into that. A lot of demand responsive controls sometimes will be something that will come into play. Again, remember, there's a difference between expecting the minimum and then evaluating what is on a particular design, right? And I use this example a lot in the concept of the thermal envelope, but it applies in every element as well, right? If just because the plan says the minimum is the code says the minimum R value is 13, if that plan as it gets approved is for an R30, guess what should be in that wall? An R30, right? If the plan does not require a particular type of equipment, if the code does not require a particular type of equipment, but the plan says it's supposed to be installed, then we should make sure we, as protectors of the public interest in our communities, we should be looking out to make sure that what's on our plan is what gets installed. And so that's part of that relationship, right? It's the approved drawing. It's the way it's supposed to be. And so that insulation, understanding the different insulation values associated with water heating pipe, water service heating pipe, because again, we're trying to maintain how much. We're not trying to heat that water within the pipe. We're trying to take the chill off the pipe so that it doesn't have that thermosiphoning that we see happen when water passes through that cooled pipe, especially when we think about the climate that we're in. Some other considerations, and I know we don't have too much time left, but some other considerations that come into play when we think about commercial construction is going to be the concept of power and lighting, right? Lighting controls and power calculations are important elements when we consider how a building operates, and they're very easy to identify when we think about when does an HVAC system operate, how do we control zones, how does the lighting operate, right? It does no good to control the building thermal envelope without windows. It does no good to control the envelope with no consideration for the HVAC. It doesn't help us to think about all those systems and then ignore the lighting, right? So it's all part of this holistic approach of how does the code approach a building's operation and the conservation of energy as well as the conservation of equipment, right? The more a light is on, the more it's going, and different equipment is running and operating, then we run greater potential that we're going to burn a system out. And so the code provides for us a variety of different expectations for all compliance paths when it comes to following the mandatory provisions. There is no simplified building, but when we think about with the mandatory, we're looking at the concepts, which we know has been removed in the the state code, the concept of of automatic controls, the concepts of what types of power lighting allowances are we including, incorporating? Are we using the building area method, the space by space method? If we think about it in the context of the building area method, again, think about it. If I'm looking at a building, I'm going to choose a very simplified evaluation of that system. I'm going to say, okay, this is a library. And so as a library, it's going to have a specific value that the table tells us should be applied when calculating how much energy should be used for lighting. Whereas that may be different if we look at the space by space method when it comes to the calculation of maybe different spaces within that. So we may have office space that's treated different from warehouse space, or backroom space, versus open auditorium style spaces or reading areas. So again, when we think about different lighting capabilities or lighting allowances, or how we use energy within the building, we're thinking about in those contexts. And sometimes it's important to evaluate from a design perspective how we're going to look at what interior lighting allowance we're going to utilize, right? Again, building area, easy. Space by space is a little bit more specific to maybe a design. So if you have a huge backspace and a very small open space for maybe where we have lighting for maybe displays or merchandising or sales, then you may choose a different path. But again, that's calculation, that flexibility exists there for the design professional. Same concept when it comes to our understanding of additional requirements when it comes to if we're going to be following that energy cost budget calculations, right? And so they're gonna provide for us again. What are we doing? Are we looking at lighting systems that can and equipment that follow all these different requirements? And then again, are we going to be utilizing that energy cost method calculation? Same concept when it comes to exterior lighting power allowances as well. We think about how buildings operate in reality. And so we're looking at a simplified methodology for exterior lighting control. And so that's going to be identifying the tables associated with different types of buildings that we may be operating. And then we're going to be evaluating, what it is in that exterior, that building exterior. I think that's what I did. I talked through them instead of reading through them, right? And so what we'll be looking at is again, what are those different expectations for lighting conditions? And so we're going to treat things differently based on, are we looking at maybe facade lighting versus parking lot lighting? Are we looking at the different, what types of timers, or when do we need to have vacancy sensors or occupancy or motion sensors? When are we evaluating safety versus, just general lighting for a particular area? All of those considerations come into play when we start calculating some of these different designs. And again, when we think about how we're going to demonstrate that compliance, that's when we're going to go back to the code. And those plans are going to tell us, what are we expecting to see? When are we thinking about the different areas of that building, both from an interior and an exterior perspective? And again, when we think about the different lighting controls that go with it, because again, power allowance is nothing if we don't consider how we control that. Remember, it's all about control. And so it's how do we actually utilize and control systems like parking lights and exterior lighting. One of the examples that one of the code provides recognizes, again, if we're utilizing timing allocations for buildings that don't operate 24 hours a day, right? So I've got a project that I'm very familiar with that they close at 5 o'clock, and at 7 o'clock they're on a timer and their lights turn on every day. Now at this time of the year, 7 o'clock the sun is still out, but yet their lights are on a timer. They're not on a photometric control, a photo cell control, right? And so the code identifies for us different expectations for the different types of equipment and controls that go into place in these systems. And then the code also provides for us, again, a variety of different equipment identified in chapter number 10 that drives in the concepts of electric motors, elevators, air curtains, pumps, different elements that may be utilizing both a variety of different impacts. So when we think about it from a mechanical perspective, as well as from a maybe an an electrical power calculation, we can evaluate these systems and how are these systems operating? When are they drawing down? We were recently in Duluth, and Hope and I went to the elevator, and the elevator had de-energized. It had been a while since anyone had been in it. It had de-energized. It was actually it was kind of funny. We sat there for a little bit, trying to hope that it would de-energize, and we could get a great little shot of it or video. But again, making sure those systems, when not being utilized, are not being a draw on the system. I've used the example before where we're talking about equipment longevity as much as energy conservation. A project I know of utilized was more of a theater application, and so they didn't use they had a variety of lights that were supposed to have some controls installed. Controls were never the appropriate controls were never installed, and so the lights had never turned off. After almost 10 years of being on, they started to experience mass failures in their lighting system. So they called the county, they called the building department, because they thought they were having some kind of a wiring issue. We've got some kind of short somewhere. Can you come help us? In all reality, what it turned out was, no, you've just never turned them off. They've been on for 10 years, and now they've worn out from operating 24 hours a day for 10 years. And so now you're seeing these mass failures. And so one of the things that we ended up redoing was they put in the appropriate fixtures and controls so they would be able to properly de-energize their systems. And again, it's not necessarily, there was a little bit of financial savings and energy conservation there, but it was more about how are they going to deal with their equipment calculations. So I know we got about 15 minutes left, and hopefully somebody's got some questions. But one of the things I think is, again, wrapping up, the critical concept when we think about overall high level design considerations for building projects is always to identify what is the compliance path, because that compliance path is going to drive for us all of the other elements as far as what are our expectations when it comes to into the plan review process. Identifying that thermal envelope is a critical component when we think about how that building is going to operate. When we identify and separate out semi-heated spaces from heated conditioned spaces, again, remember we're modifying, and if this is we use this project for another project, this is more of a semi-heated space in this corridor, if I remember correctly, or a similar project. The corridor is a semi-heated space, but above that semi-heated space is the HVAC system, the ductwork, and so that ductwork has to be treated differently because it's in a semi-heated space versus being part of the conditioned area, being completely within the building thermal envelope. So again, evaluating where and what is within the different elements of the building thermal envelope is a critical component that drives the conversation about how do we properly ventilate, how do we properly heat and cool that space, and then again, what types of lighting fixtures and controls are we putting into a building? Because again, those are going to be calculations that really drive energy consumption. And when we think about different occupancy type controls, I just got done teaching a class on occupancy controls and different lighting considerations. Again, if you're thinking about it in the context of top lit or side lit, daylight zones, that can really have an impact. If we're going to have a space, a building that operates in an area with a lot of open windows, right? If we're thinking about this kind of a building, and we've got a lot of windows, we've got a lot of light coming in. Now, what this one did is they integrated some solar panels into their windows. But when we have a lot of light coming into the building, then if we don't have the appropriate daylight sensing controls, then we're spending energy that we didn't need to because we've got adequate lighting. Now the question is whether trade-offs are still allowed within this new code. Yes, the trade-offs still exist within the compliance paths that we've identified, and that flexibility, especially depending on what we're talking about, that flexibility is really something we need to remember. When I have the flexibility to, this is a maximum value, right, for my U factor, my solar heat gain. I can look at and I can do that building trade-off through the compliance path for the building thermal envelope, right? I can use my CompCheck, I could use a RIM rated E-Control, one of those other software systems to provide me that envelope evaluation. And then we can also look at the whole system, right? We still have those other compliance paths for energy cost and performance rating, right? So we can still look at maybe trading off more of those envelope values for more efficient HVAC equipment. And then we've also got the recognition that there are going to be, again, other trade-offs. I mean, trade-offs are exactly what we're looking for, right? And so that flexibility exists in the 21 or the 24 code for that reason. Now, I'm going to do a little bit of housekeeping, so the conversation's not over, don't leave. So when you leave, as you leave, you should fill out a survey. Please provide any questions and information that you can. That helps us understand what's the appropriate type of future trainings to bring along. As far as future trainings, we're going to look at commercial inspections next week, and then we will not be here for July the 4th. That'll be, but we are going to bring back some conversations looking at air barriers, installation design, and plan review. And then later in September, we'll look specifically more of a deep dive into mechanical systems. As we've talked about before, there are a variety of different in-person opportunities for you to take part in. We are moving a lot of our events around. This is an example of one that we're partnering with MAPMO, the Minnesota Association of Plumbing and Mechanical Officials. We're going to be facilitating and training at their project. So if anyone's interested in attending, please feel free to register. Reach out to them. You can visit our website. We've got a link to an email there. That'll be on the 17th, and that's going to be a 3-hour training looking at mechanical system design in a much greater in-depth detail. But we recently completed our training up in Duluth. On Friday last week, we've got one scheduled for Bemidji up in Minnesota MnDOT District 2. What we're trying to do, just so that you're all aware, is we're trying to move those around, hit every district, so that we get a good coverage across the state. We're trying to find locations that make sense. And so again, that's there. We're doing that. That's a free training. Again, it's going to be about 4 hours. It's doors open at 8. Class starts at 8:30, and I'll run until about 12:30. And we're going to be looking at the thermal envelope, looking at compliance paths, and really talking about it in this application. We're going to be looking more at it from a design and plan review. So there's going to be a lot of plan review elements to that. What we've kind of decided for this first year, for this first couple sessions, is we're going to take more of a series approach, so that you can it's not the same conversation each time, but it will also move around, so that you can get them all without having to follow us like a groupie. And so you can participate in this. Again, this is going to be the design, more of the plan review considerations. We've already got one scheduled for July the 31st up in over in Monticello, and so that's going to be on installation and inspections, right? And then we'll flip that around, and on the next group we'll go back to that rotation. So we'll have a 3-course rotation, so that again, if you can make the 1 or 2 of them, and they're going to like I said, really kind of differentiate, and there are a lot of different opportunities for looking at to help provide that free training outreach to you guys. So if you have any questions, please always feel free to utilize the code helpline. You can go to the website, you can provide those questions, comments, any question you have. We'll respond to them, and then over time we will curate and put them into a frequently asked questions section anonymously, so that no one knows that you asked the question specifically, but more importantly, to help us get to make sure that we have access to information, because we understand that we need to grow together. But like I said, I think those opportunities for those in-class, in-person trainings are really valuable assets. And again, we will try to give you as much advance notice as possible when we offer them in the different areas, so that you can make them, maybe share them with your local building department, not only your building staff, but your building contractors and your design professionals that you have a relationship with. Because again, we want to make sure the entire group is there, and that we'll be available to assist. I know we've got a few minutes left, and don't mind me. I mean, I'm okay with having a few minutes left. Does anybody have any questions or comments or about some of the things that are coming up? Again, I think the critical thing for us to understand is that when we have fully understood the concept of why we exist and why we're looking at these different concepts, then we can figure out the how. We can, and more importantly, when we think about it from the design perspective, that inherent flexibility is critical for us to understand how inspections go in the field, right? If I understand the rationale, we use this example when we talk about building thermal envelope. It's one of those things that we really kind of underappreciate at times. But if I understand that building thermal envelope is that particular material choice, when we talk about insulation, right? When we think about, and this is going to be a function or a part of the conversation we'll look at in our next in-person class. But when you design a building, considering the different types of insulation that are available, you may be making a decision based on a particular, not only thermal resistance, but on other component values, right? We understand that the materials like rigid insulation provide not only thermal resistance, but can also provide a level of water resistance, right? Or vapor resistance. That certain types of spray foams may be used also as air barriers. And so understanding that those materials are going to be in place for more than just thermal resistance helps ensure that the project, when inspected and installed, actually goes the way we want it to go, right? If if I don't properly designate and all I see is that I'm putting in an air cell, I'm putting in a spray foam at R20, and I'm not aware, if it's not clearly defined in my construction drawings, construction documents, that the system is also providing the air barrier, and the contractor replaces it with a 20 batt insulation, then I'm not going to be able to make sure that project is successful the same way. Knowing how these systems are being utilized allows us that ability to say, no, this is also the air barrier. So if we're going to modify and go to a 20 batt, then we need to also identify what's the replacement for an air barrier, and vice versa. So again, how can we utilize making sure that these systems all operate well? And I know that, and maybe what we'll do real quick is I'll take a very, just to make sure you're still all awake, okay? Because I know I can sometimes drone on. If I could get you to raise your hand if you are a design professional, if you do design professional work, raise your hand on the, we'll do a quick survey. Okay, so we got a couple. We'll wait 2 seconds and then I'll tell you, you can put your hands down. If you are a plans examiner, raise your hand. This gives us an idea of who all is on. Okay. Give you 2 more seconds. Put your hand down. And then if you are an inspector, raise your hand. Okay. Okay. And then if you are, and I know I might get a couple people because I didn't warn you beforehand. You can all put your hands down. If you are a building official or all around, I do everything but catch dogs, raise your hand. And then some of you may actually be the dog catcher. I know that. Right? Good. So again, that just helps us better understand the type of classes and how maybe to focus them. Do we have any, I'm going to ask, do we have any contractors, actual installers or contractors online today? Okay. I see one. Okay. 1 or 2. So good. Again, that's really what we're trying to look at is making sure that we provide the resources, provide education in a way that's manageable, understandable, and relatable. And so when we start, if you get a chance, check out the website. You'll find a variety of different resources there, and we'll be adding more resources as we continue to move forward. But again, what we're looking for is providing you resources. We will be reaching out to you, just so you are aware, to do what we call a friendly visit. It is not to do anything crazy. It's literally to make sure that we're doing the best we can to help you. And so, we'll reach out to you individually, maybe swing by your community and say, hey, are there documents that we can help with, videos we can facilitate? I know one of the conversations we had last week involved reaching out and having that conversation. Brenda, I'm going to unmute you if you want. I don't know if you want to talk or not. But what we'll do is, if you want to talk, feel free to unmute yourself. But go ahead, Brenda. Can't hear you if you're talking. But one of the things that we'll try to do over time, like I said, is trying to get with each community, make sure that what we're providing makes sense. When we were up in Duluth, I think we're at I Falls, and it was really a conversation that Hope was having, and it related to, less words, more video when it comes to things that we can provide to you on the website, right? We want to make sure that, if it's identifying the proper way to flash a window, or if it's, doing a 2-minute, 5-minute video, as well as a 1-page handout on something, that's really what we're looking to do. But again, though, that's what we're here to do, is really just to see what product or what technical resources, expertise can we bring. Hope and I, like I said, we travel a lot. We do a lot of classes from around the country, and so we get a lot of experience and talk with a lot of people. But we always want to make sure that we are respecting you and what you want to get. So again, when you go out, feel free to fill out the survey. If you have any questions, feel free to reach out to Hope or I, or visit the website. You can always submit a comment there. And then, like I said, you'll get your certificate for attending, as well as the handout. Hopefully within a couple days. I'm going to try and get it done today, but I've also got some other classes, so every time I say today, it never happens. So you guys have a great week. I appreciate it. We'll see you in 2 weeks again on the 20th, and we'll be talking a little bit more about the inspection side of it. So I appreciate you guys. Have a great week. Enjoy your week. Be safe, and we'll talk to you soon.
Hi, everyone, and thank you all who attended the training a couple of weeks ago. That was fantastic, and we look forward to chatting with all of you and seeing you in a couple of weeks. Bye, everyone.